Let's start again. All right. So you know what's funny is that you can't have any music playing in the background, or else Google's gonna know that you've got music going on in the background, and they will say that it's a copyright infringement. It's hilarious. Anyway, all right. I'm gonna share my screen with you.
Okay.
And present to everyone.
Oh gosh.
I know. But then you're gonna get my work. Do you see that?
Yes.
All right. That's what we got, right, so far?
Yes, ma'am.
All right. And so we have to integrate this from 0.5 to 1.5. So let's see what we got, right?
Mm-hmm.
The integral from 0.5 to 1.5 of, we'll take the 2 pi out in front, right? Because that's a constant.
Mm-hmm.
And we know y is the square root of 2x minus x squared. And then the square root of 1 plus, well, we got to take the derivative, which you're really good at, I know. Y dx is power down, right?
Power down,
Function
lower the function 1
times
the derivative of the inside.
Which is?
2 minus 2x.
Mm-hmm. Now we can factor out a 2 here, right?
Yes.
So that's going to be 2x minus x squared to the negative 1/2 times, and I'm going to get, this is 1 minus x on top. Okay, and then and I just canceled the 2's in one step. Are you okay with that?
Yep.
All right, and now I'm going to put things where they belong. So we get 1 minus x over the square root of 2x minus x squared, right?
Mm-hmm.
And then we got to put this thing in here and square it. 1 minus x quantity squared. I'm squaring the top and the bottom. We'll just take this off. Square root out, right?
Mm-hmm.
And then we're going to put a dx here. You understand how we got that? Does she understand how we got that?
Yes.
Okay. All right. So now what we have to do to integrate it is we got to find a common denominator in here.
So multiply both sides by 2x minus, or just the 1 by 2x minus x squared.
So we're going to get 2 pi integral of 0.5 to 1.5. And actually, yeah, you could bring this, you can multiply this in, actually.
Okay.
Because when you have the, the properties of radicals, sorry, my pencil's red. With the properties of radicals, the square root of a times the square root of b, the square root of ab. So you can multiply that in.
Okay.
If you want to find a common denominator first, I'll let you just decide.
If we find the common denominator first, will stuff like cancel out easily?
Well, what's interesting is if you bring this in here, this is what I would do. We'll just make a big square root, and we'll say 2x minus x squared times, we'll find one big common denominator, which is going to be 2x minus x squared. Yes, it will cancel out. Right, and then we have to multiply this by
1.
By 2x minus x squared. Do you see that?
Mm-hmm.
Because that over that's 1. Plus, and then we're going to say, I'm going to expand the top, which is 1 minus 2x plus x squared dx. Do you follow what I did?
Yes, I do.
Okay. So what's going to happen nicely is this is going to cancel with this.
Oh, that's very nice.
It's very nice. And then we're going to get on the outside here 2 pi times the integral from 0.5 to 1.5 of the square root now of, and what happens to the x squareds? They go away. Oh gosh, and the 2x?
And the 2x goes away.
We're left with what?
Square root of 1.
Square root of 1. Well, and my square root's way too big for the square root of just 1.
I did that too.
Okay, so we have a dx. And a square root of 1 is just 1. So this is going to equal 2 pi times the integral from 0.5 to 1.5 of dx. And the antiderivative of 1 is just x, right? So this will be 2 pi times
X.
x evaluated between 0.5 and 1.5. And so we can say, and 1.5 is the same as 3 halves, right? So this will be 2 pi times 3 halves minus 1 half, right?
Mm-hmm.
And that's just 2 over 2?
Which equals a 1.
Oh my gosh, so this is 2 pi units. That's the right answer? It is.
Yes. See, this is so much better. And then, poor girl, the girl who was like doing it on the board doesn't speak English that well. So,
right.
Yeah.
Okay, so I guess the bottom line is when you're trying to solve this thing is that you got to know the formula.
Mm-hmm.
And then you plug in y, and then you got to take the derivative, which I know you can do, you know, with the power combined with the chain. And then you have to square this by putting it in here. And then I think I'd find a common denominator and bring this in at the same time because you can use it with the properties of radicals. But anyway.
Awesome. All right. And then problems with work.
Okay.
So I'm going to go over a few like word problems.
Sure.
And just take pictures of the book. This one was one that was giving me trouble. Trying like not to get the glow of the light. Okay. Let me know if you can read that well once it's sent.
Okay. I'm waiting for it. Yeah, at BT we're going to have a House Olympics next Wednesday.
Oh, that's fun.
Well, except that we're going to have 55-minute classes.
Why wouldn't they just cancel classes altogether?
You know, it's like our field day. Mr. Moore said when I went to dinner with him after our open house, because we always do that as teachers, you know, the mini class night, the math department always goes out. And Mr. Moore met us there, and he said he always said no way to field day because he just thought it was way too chaotic and you know, so.
I'm sure it's going to be fun.
All right, so the pumping water one.
Yes.
Okay, let's see what we got here. Okay, so work is the integral of times distance. Okay. Let me get my IP back up. Okay. So work is the integral from A to B of f of x times some distance. Like this is like a force times some distance. Okay. Now, this says a rectangular tank shown here with its top at ground level is used to catch runoff water. Assume that the water weighs 62.4 pounds. So water is 62.4 pounds per cubic foot. So what are they telling us when they tell us that? Pounds per cubic foot.
That's the.
I'm trying to think here.
Would that be like the work you need to put in? No. That's the force.
Well, that's going to be pounds per cubic foot. That's like a weight per volume. Now let's see here. All right, so my book, and it's been a while since I've done work, but my book says that the force, and I guess this is going to be in the y direction, right? Because we're moving it up.
Yeah.
The force in the y direction is going to equal the weight, which is 62.4 pounds per cubic foot, times a change in volume. And that's going to equal 62.4. And the volume is going to be in cubic feet, So that'll cancel out the units there.
Mm-hmm.
And what is the slice of that volume? A slice of that volume is going to be delta y times
Delta y times.
y times. Okay, so it's 10 by 12. So it's going to, right? Because the delta v here is going to be y high.
Mm-hmm.
Delta y high. Let's try delta y high. Delta y high, and then it's how long? It's going to be 10 by
10 by 12.
Okay, so that's going to be, isn't that the volume of a slice of the water?
Yes. Mm-hmm.
All right.
Yeah, length times width times height.
Okay, so that's going to be times 120. The delta y. Because we need it in because weight itself is a force in pounds. We just had to get rid of the per cubic feet.
Yeah, okay.
All right. And so work is going to be, let's see what that says here. How much work does it take to empty the tank by pumping water back to ground level once the tank is full? Okay, so how tall is the tank? It goes from zero, wait. It says how much work does it take to empty the tank? So it's going to go from 0 to 20?
Yeah.
Or negative 20 to 0. I think it's going to be negative 20 to 0 because we're starting below ground.
Mm-hmm.
So I think work's going to be the integral from do you see that negative 20 to 0? That because we're starting down below in the picture, down at negative 20, and then we're raising it up.
Yeah, the 20 is below, like underground.
Right.
Yeah.
And then we're going to say f of y.
So 62.4 times 120 delta y, but we'll need a.
And this turns into a dy. It turns into a dy.
All right. Do we?
Okay, but it says the distance through which f of y must act to lift it. So we need going to be 20 minus.
20 minus y?
Yeah. Yeah, I think it's that. But do you have the answer? So do you know what the right answer is?
Yeah, I have the answers in the back of the book.
Okay, good. So we can check it, right?
Mm-hmm.
All right, so this is a constant here, so I'm going to pull that out, 62.4 times 120 times the integral from negative 20 to 0 of 20. Now I use 20 minus y because that's how deep the tank is,
Mm-hmm.
y. And then we can integrate 4 times 120. And that's going to be, if I integrate it, it would be 20
Y
minus,
squared over 2.
right, evaluated between negative 20 and 0. So let's see, 62.4 times 120 times, it would be, what happens when I plug in 0? I get 0, right? Like
Yeah.
And then minus, and then when I plug in negative 20, I get negative 400 minus, that's going to be 400 over 2.
Minus 8. 2 minus 200. Yeah.
All right, so that would be 62.4 times 120 times, well, that's going to be a positive 200, right?
Mm-hmm.
And so if we multiply that out, I gotta get my calculator. Going anywhere? I'm just going upstairs to get my math error, so you can tell me.
Okay.
That gives the right answer?
What?
That's the right answer?
Yes.
What addition do you have?
Excuse me?
What addition do you have?
I have, as my answer, I have 1.4976 times 10 to the 6th.
And that's going to be in foot pounds. No, your book. What edition is it?
Oh, sorry, I couldn't hear you. It's 3rd edition.
Is it by, who's your author?
Hayes, Ware, and Thomas.
Oh, okay. I don't know what edition mine is here. I tutored somebody once, and this my only fee for doing it was I wanted her book, you know, because I collect books.
Yes.
And it was a family friend, a family friend's daughter, and I didn't want to take any money. And I said, well, gee, you can do it. You can just not send back the book, and I'll take the book. And so they, this must be the 1st edition.
Yeah, mine's the University Calculus Early Transcendentals 3rd edition.
Mine must be the 1st edition. Okay, but so you're in what chapter?
I'm in chapter 6, section 5.
Okay. Yes, I have that book. I have it. So I have this book, and it's number 13. I have the book.
Yay.
I had to turn the light on so I could see.
Yeah, I'm like kind of in a dark space. I had to find a good video chatting spot. And this was the best spot I could find.
Well, you are at Georgia, and I know it's busy around everywhere, right?
Yes.
All right. Hang on, I'm going to put a shade on my camera. You can see it at least, right?
Mm-hmm.
All right,
I can also see it fine without the
shade?
Yeah.
Okay.
If it's too much of a bother.
Well, it's on now, so. All right. What's next?
All right, and then the second part. So that was
part A, sorry. Part B,
then,
if the water is pumped to ground level with 5 divided by 11 horsepower motor, work output 250 foot-pounds per second, how long will it take to empty the tank to the nearest minute? So that sounds like we are going to multiply the foot-pounds that we got times 250, right? Does that, because the units will.
yeah, the units will cancel.
You have to tell me if that's right.
It looks like, oh, you have to divide.
Let's see, foot-pounds. Oh, right. Yes.
Flip.
Yep, right, because the units, so for part B, it would be 1.497 times 10 to the 6th foot-pounds. And, oops. Foot times, I can't write. Gracious, foot-pounds. And if you divide by 500 or 250 foot-pounds per second, then what happens to the seconds? They end up popping up on top.
Yeah. And then you have to convert it to minutes.
Oh, yeah, because it's in seconds. Now, why on earth would anybody on a calculus test want to make you convert units?
Yeah, and get this, we're not allowed to use calculators at all in the course.
Well, how are you going to do that? By 250, which is 5,988 seconds. Is that what you get?
I don't think I plugged it in right, but.
And then if I divide, okay, so how many seconds are in a minute? We got 1 minute and 60 seconds. I'm going to divide that by 60. And then I get approximately 99.8 minutes. Check the answer in the back. I loaned this book to Mrs. Reagan, and her dog ate the corners of it. It's hilarious.
Oh no, must have been tasty.
Yeah. You know, they have 1 hour and 40 minutes.
Could they have like grounded?
Well, okay, so 99 minutes.
Is almost 100 minutes.
Right, so 99 minus 60. Yeah, so it would be 1 hour and 40 minutes. That's right. So approximately 1 hour and 40 minutes. It's 39.8 minutes, you know, but now, would I want to do that without a calculator?
No.
No. Hold on, that's my husband on the phone. Hang on. Hello? Yes. Okay. All right. Well, I am on Google Chat. Hang on. And I'll talk to you when you get home. All right. Love you. Bye. We just got home from Savannah.
Oh, fun.
Yeah. All right. Part C says, show that the pump in part B will lower the water level 10 feet halfway during the first 25 minutes of pumping.
So we're going to have to do the same integral, but this time from
Negative 10?
negative,
No, negative 20 to negative 10, right?
yeah.
Yes. He's going to have to give you some nice numbers if you're not using a calculator.
Well, he also doesn't like require us to simplify all the way,
Oh, okay.
but like even sometimes like doing the integrals like this, or like even the surface area ones are just so hard to do sometimes without the calculator.
Right. Well, now I wonder if it's going to change here, the 20 minus y. No, no, because that'll still be the height.
And then pull out the 62.4 times. Let's simplify this a little bit. Oh, 62.4 times 120 is 7,488.
Okay. Here's 20y minus y squared over 2. Evaluated between negative 20, negative 10. Which equals 0.88. 9. Well, that's going to be negative.
Minus 200.
100 squared is 1,000 divided by 2, right?
Yes.
Oh, no, it's 100. 100 divided by 2.
So, yeah, 50.
Minus 50. Minus the second part of the integral up there, which turned out to be just 200, didn't it? Minus 200.
250. Those.
Look at the negative number.
I don't.
You know what I mean here? If I plug in negative 10 here, I get negative 200 minus 100 over 2, which is negative 200 minus 50. And then when I plug in this, I get negative 400 up here, like I did up here, minus 200, which gives me a negative 200, and then it becomes positive, which I got down here, and then this is negative. So I get a negative 50.
Negative 200 plus negative 50, but it's not in. Well, the answer isn't in the back of the book for part C for some reason. A, B, D.
Maybe I didn't like it either. Let me read it again. It says, show that the pump in the water will lower the water. Show that the pump in the water will lower the water level to 10 feet. Halfway. So would it be -10? Would it be -10 to 0 instead of 20 to 0? You know what I mean?
Well, when I did it +10 to +20. Like I kept all the numbers positive, but I still got the same answer, just positive.
Well, what I was thinking is that if, okay, then it would be 780, 74889. I'm going to put -50 here, but then, of course, we don't know what the answer is, so.
Yeah. Well, I got -374,400. And I guess you have to divide that
by 250.
So in the first 25 minutes of pumping.
And that's right. And you get 14.976. Is that what you got?
Divided by.
That's seconds. And then divide that by
60. 24.96.
It is. That's 25. Boom. Well, I guess they were saying it's a 25 minutes, right?
Yeah.
So.
All right. And then D.
And then a negative here is just the direction, you know, whether it's plus or minus. All right, part D.
What are the answers to parts A and B in the location where the water weighs? Okay, I think I can do this on my own.
Yeah.
All right. And then we started the concept yesterday of moments and centers of mass, section 6, chapter 6.
Mm-hmm.
And honestly, I'm just a little confused. Like, we didn't get to any practice problems. Let me check to see if he posted any homework assignments. Oh, he sent a practice test. Oh, that's nice.
Right.
Okay, so I'll see. Oh, we can do some of these problems.
You see, a little bit like your old calculus teacher. She did the old practice test too.
All right, I'm going to forward this email to you with the attached. And it's going to be a weird, like my initials with some weird number as the email. All right, let's see if you get it. Oh, I did not expect this from him.
Hello. gosh, did he send you no? He didn't send you any answers.
No. He just sent the.
All right. You want to work these together?
Yeah. Yeah, let's do some of these. Let me get some paper. So we've covered how many sections? 1, 2. I think that's one question from each section. So I don't think this test is going to be, I mean, we only have 50 minutes. Oh, wow.
Oh, right. Well, you should, okay. So yeah, I don't see any of the moment stuff on here.
It's number 7. Number 7's a moment 1.
No, it's just, oh, at that moment, the barrel, no.
No?
It's asking how much work is done in raising the barrel.
Oh.
It's work.
Oh, that's good. He said it would be on the test, though. I could ask him tomorrow. I have class tomorrow, too.
Yes, as an empty barrel is sitting on the ground, that moment the barrel begins to be lifted. It continues to be lifted at a constant rate of 0.3 meters per second. In the rope is weightless. The barrel has a mass of 1.5 kilograms. At the same time, sand is being poured into the barrel. How wonderful that is. Okay, all right.
All right, let's.
Okay, I was going to do my IP vote. Here we go. So that's the first integral. How are we going to solve that?
Substitution.
Yes. So we're going to let u equal
ln of x.
Yes.
And then du is 1 over x dx.
And that's going to be then, it's not equals, so don't say equals, just say it's going to be the integral of u du. Now, has he in the past made you change these, this integration in terms of u?
He says we can do both.
Well, I would do it our way, right?
Yeah.
So when
I
you
like our way better.
when you integrate that, we're going to get
U squared over 2.
And then obviously, I'm not even going to show the plus. Let's see, because we're going to take this now and bring it back. And say the integral is going to be what? Ln
Ln of x squared
over 2 evaluated between
3 and 6.
which is equal to Ln of 6 minus Ln of
3 squared.
Now, we can't.
If you can't do anything further,
No, I don't think so. I think we're stuck.
yeah, I'll leave it at that.
Okay. Number 2. Look at number 2.
Draw the graph of y equals sine x with 0,
0 and 2 pi.
pi. Mark the point on the graph with exponent pi over 4. Also marks the point with exponent 2 pi 3. Draw a straight line between these 2 points. Okay. So sine on the midline.
Yes, ma'am.
And then pi is 0. And then pi over 2 is 1.
We're going to go to pi over 2, it's 1. And 3 pi over 2. Now 2 pi over 3 is before pi. We're going to fix that. Pi over 4 is here, and then 2 pi over 3. So that's root 2 over 2, and then 2 pi over 3, the sign is
Negative 1.
no, it's positive. 2 pi over 3.
Oh, 2 pi 3. Yeah.
It's 3 over 2, which is 0.866, so it's higher than the 1. That's root 3 over 2 high. You want to draw us a line between them?
Okay. And then find the area of the region in that first quadrant above the straight line and below the graph of.
You know what that means? We need the equation of that line, right?
Looks like we do.
So the slope's going to be, so what's the point? Oh, that's gross. So what's the point? It's going to be pi over 4.
Pi over 4. Root 2 over 2.
And then the other one is pi over 3. Root 3 over 2. So m is going to be root 3 over 2 minus root 2 over 2.
And he's not letting us use a calculator.
Pi over 3 minus pi over 4. All right, well, the top's going to be root 3 minus root 2 over 2. They have the same denominator. The denominator on the bottom is going to be in 12ths.
So it'd be 8 pi minus 3 pi over 12.
Yes. Yep. And so we're going to have 2 cancels, and then this goes to 6 because they're both in the denominator.
Yeah.
And then I can bring the 6 up on top and say 6 times root 3 minus root 2 over 5 pi. That has to be the ugliest looking slope I ever saw in my life.
I would have to agree.
Okay, but we just need point slope form, don't we? We just need, which point? Let's use this point here. So what's the equation going to be? It's going to be y
Minus
root 2 over 2 equals m.
this ugly number.
Over 5 pi times x minus pi over 4. Right? But I got to have it as y equals, so I'm going to move the root 2 over 2 over, but I'm not going to add it. You know what I mean? I'm just going to add it and leave it.
Yeah. Oh my gosh.
You know, maybe this will be the test tomorrow or on Friday, and the fact that you did it, you'll be able to do it in 50 minutes. You know what I'm saying?
I mean, our quizzes are straight up homework questions like that he just picks.
Right? All right, so we're going to go upper minus lower, aren't we?
Yes, we are.
And the upper is sine x, thankfully.
Oh my.
Oh, sorry. So it's going to be area equals the integral from pi over 4 to 2 pi over 3, right? Because that's the limits right there.
Mm-hmm.
The upper is sine x minus the lower, which is this obnoxious.
Oh my gosh, how am I supposed to integrate that?
You know, the only thing that matters when you're integrating is that lonely little x over here, because this is just a constant.
True.
So don't let it freak you out, not for a minute. Times x minus pi over 4 plus root 2 over 2. And I'm putting parentheses around that, and that'll be dx. Okay, so yes, it's ugly, but we know that the antiderivative of sine is negative.
Negative cosine x.
So this will be negative cosine x. And this is just an ugly constant that's going to stand out in front of that. So it'll be minus
Minus
6 minus root 2 over 5 pi. Now what's the antiderivative of x? Well, that's just
x squared over 2.
Minus the antiderivative of this is just going to be pi over 4x. Right?
And then it's root 2 over 2x.
Root 2 over 2x. And then, I mean, that's that, right? We're going to go from pi over 4 to pi over 3. Now,
all right. The negative is negative. Okay, so negative cosine of pi over
2 pi over 3. Right?
2 pi root.
And cosine of 2 pi over 3, if you do the finger thing, is negative 1/2. So this is going to equal a negative 1/2 times negative is
1/2.
And then we're just going to leave this little gross thing. 6 times root 3 minus root 2 all over 5 pi times, well, we're going to say 1/2 times 2 pi over 3. I'm going to bring the 1/2 out in front.
Mm-hmm.
Minus.
And that's, yeah, minus pi over 4.
Pi squared over 4. No, over, yeah. No, when I put 2 pi in here.
Oh, yeah. Mm-hmm. They cancel, so it's pi squared over 3.
Right, over 6, right? Because only one of the 2's cancels.
Oh, right, yeah.
Squared over 6. Plus.
Oh, gosh.
Cancel. And then pi root 2 over 3, right?
Yes.
And that's
The
only
two's
one part. Minus. Now we're going to plug in pi over 4.
Cosine is negative root 2 over 2.
Minus that ugly thing that we don't care about what it looks like now. Times. Now we're going to plug in what's going to be pi squared over 8. No, because we're squaring the whole thing.
Yeah, pi squared over 16.
Minus pi squared over 16. Is that right?
What happened to that 1/2?
So
Like,
that's over 32 then, right?
yeah.
I'll put it in those 2 steps because I can see what happens when I don't do it in 2 steps, Patricia.
Happens to the best of us.
Yes. And that's pi squared over 16. Plus. pi 2 over 8.
And that's the answer. I'm going to leave it at that.
Oh my God, yes. I mean, what else could you do in 50 minutes?
Cry.
No, you're not going to cry, right? Because you know the mechanics, right?
Yeah.
And is this, see, then my question would be, is this a calculus test or is this the endurance? Can you figure out, all that petty algebra?
Probably more endurance than.
But he is the teacher, so he gets to be in charge. Okay, so let's see, number 3.
Find the length of the curve.
Okay, so the formula for the length of a curve, hold on, let me write what y is. Y is 1/2 e to the x plus e to the negative x. I'm going from 0 to 2. Nice hint that he gave us there.
Arc length here.
Yeah. Arc length, is this, all that is a formula.
Arc length's formula is
Integral from a to b, square of 1 plus y
prime squared.
Okay,
And then,
you got to find dy dx.
y.
Yeah, that's going along for the ride.
And then it's e to the x
E to the
plus
x
minus e to the x, e to the negative x.
Yep, that's nice.
Yes, and then you square that all.
And put it in here, but we'll put it in here. We'll say equals the integral from 0 to 2, the square root of 1 plus. Now I'm just going to make this 4 on the bottom. So it'll be e to the x minus e to the negative x squared over 4, right?
Yes.
X. And now we need to expand this top and find a common denominator. The common denominator would be?
4.
It would be 4 plus. When you square this, it's going to be e to the x plus times the x minus e to the negative x. When you square that, that's going to be e dx times e dx, which is e to the 2x, right?
Mm-hmm.
And then this is minus 1 because they just told us in the hint.
Okay, so minus 1.
Minus 1 and the inner and the outer one is also going to be minus 1.
Minus 1.
And then it's going to get plus e to the
negative 2x.
Yeah. So that's going to be e to the 2x plus e to the negative 2x minus 2.
Okay. That doesn't seem too bad.
Negative 2x minus 2 all over 4. And we can bring a 1/2 out in front, can't we? By taking that 4 out?
Yes.
All right. 0 to 2 of, well, here, the square root of e to the 2x plus e to the negative 2x minus, well, plus 2. I forgot my dx here. Can't do that. Dx. Now, what do we wish were true? That this was a perfect square?
Yeah, but it kind of looks like one.
Yep, it does. And I'm going to suggest to you that this inside here is equal to e to the x plus e to the negative x times e to the x plus e to the negative x, and we can prove it to ourselves, right?
Mm-hmm.
E to the x times e to the x, which is e to the 2x, right? And then
That's a positive.
1 plus 1, right? 1 plus 1.
Yep, and then
So that's plus 2 plus e to the
Negative
2x, right? So this is equal to, so it's 1/2 times the integral from 0 to 2 of the square root of e to the x plus e to the negative x quantity squared, because that's a perfect square.
This is looking much better already.
And then, that's right. And when you take the square root of a square,
It's just e to the x plus e to the negative x.
and those are our most favorite functions. Right? And we can say that's 1/2
Times
e to the x,
x minus
good, e to the negative x, right? Right.
evaluated between 0 and 2.
Which is equal to 1/2 times e squared
Minus
to
negative 2.
the negative 2
Minus
times
1 minus 1, which is 0.
right. So it's just going to be 1/2 squared minus 1 over e squared. And how about this one to do?
All right. Number 4.
7.
Find the area of the surface. Y is the integration variable. Okay.
All right, so they're telling us what y is.
2 root x.
Which is 2x to the 1/2. And we're going to go from 1 to 3. Find the area of the surface as in part 1. Oh, wait. Find the area of the surface obtained by revolving the curve about the x-axis.
So we have to, part A is x, and then part B is using y.
Right. All right, so let's see here. Isn't it 2x? Surface integral. So, oh, see that in your book.
Do you need the formula?
I was just looking for
It's section 4 of my book, chapter 6.
because I've got differential equations in mind. That's probably why we made a new edition. But that section is absolutely no relation. Surface of curves. Okay. So I'm going to say that it's going to be 2 pi x, right?
Yeah, the integral from A to B. Well, we can bring a 2 pi out in front. And it's going to be y times the square root.
Okay, so it's going to be pi times 1 2x to the 1/2 the square root of, well, we have to take the derivative of this, right? So we need dy dx. would be x to the, go power down, function low to power 1.
X to the negative 1/2.
Right, which is equal to 1 over root x. So this will be 1 plus 1 over root x, quantity squared, dx.
And then that's just going to turn into 1 over x.
Root x out here. But what can we do with this root x? Remember, what was our process?
Oh, we multiply it in.
Right, and I'm going to take this other 2 and put it out here and make it 4. Okay,
So root.
Root x times. I'm going to 1 plus 1 over x. Yeah. Times the integral from 1 to 3. Oh, wait, when I say the square root of x is just x, I'm sorry. Right, when I bring the square root of x in there,
Yeah.
you get x plus 1.
Oh, beautiful.
Yes, it is. And we can use u sub, or we can just say it's going to be, because what's the derivative of the inside here?
1.
1. So du is just dx, right? So it'll be u to the 1/2, or just x plus 1 to the 1/2. And so we can integrate that and say it's x plus 1 to the
X plus 1 to the 3/2 times 2/3.
2/3 and 4 pi out in front, evaluated between
1 and 3.
So this one was a gift. And then 3 plus 1 is 4. The square root of 4
is 2 squared 8.
8. 8 times 2.
16.
So it's going to be 16 over 3 minus
1 plus 1 is 2 square root of 2 root 2 squared. Root 2 cubed.
Root 2 cubed is 2 root 2. So it's 4 root 2 over 2. Because root 2 cubed, oops, root 3. Root 2 cubed is equal to times root 2 times 2. Root 2, isn't it?
Yeah.
And then if I multiply that by 2, I got 4. 2. And that's your answer.
Okay.
It's gross, but
It's manageable.
all right, part B, we're doing it around the y. So the difference is now it's going to be 2 pi, the integral from, now we have to figure out what y is going from and to. That's the tricky part here, because this is what x is going to and from.
Mm-hmm.
With respect to x.
So we're going to have to plug it into the...
So y equals 2 root x. What happens when x, such that x is 1?
When x is 1, y equals 2.
2. So it's going to go from 2. And then what is it? Y equals 2 root x such that x equals 3. 2 root 3. That's first. Okay. And now instead of 2 pi y, it's going to be 2 pi x. We have to solve this equation for x.
So divide by 2.
So the y 2 equals root x. X equals y squared over 4.
Squared over 4 equals x. Ooh.
Y squared over 4 times the square root of 1 plus now dy, dx over dy.
So
Yeah,
y over...
which is going to be, take the derivative of that.
2y dy.
2y.
Or do you just...
No, it's going to be 2y. We're doing it with respect to y now. So when we do dy dx, we don't have to do it. Yeah, so it would just be 2y over
4, so it's just y over 2.
Y over 2. So plus, this is going to be y over 2, quantity squared dy. All right, so I skipped some steps in here. Do you understand what we did?
Yeah.
So it's 2 pi, this is x, right? And then this is dx over dy. That's the subtle difference.
Mm-hmm.
So it's going to be 2 pi times the integral from, I'm going to bring this 4 out in front. So it's going to be pi over 2. Right?
Yep. 2 to
And then it's
3.
2 to 2 root 3, and it's y squared. And this is going to be underneath here 1 plus y squared over 4 y. Now, if I want to do the same thing that we were doing and bring this y squared in, square it. Because what did I take out to get a y squared in front?
A y to the 4th.
That's right. So that's going to go. So I can say pi over 2, 2 root 3. There'll be square root of y to the 4th times y plus, let's find a common denominator.
Common denominator is 4.
Plus y squared over 4. And then we can take out, what is the square root of 4?
2. So take out a 1/2.
Yeah, so it's pi over 4, integral of 2 root 3. And now we have square root of 4y to the 4th plus
Y to the 6th.
Oh, crap. We got to complete the square.
Oh, no. Haven't.
We can have that be a square so we can take the square root off so we can integrate it.
Take the square root off. So
I'm going to say pi over 4 times the integral from 2 to 2 root 3. You can do this, I think. You can say y to the 6th plus 4y to the 4th. Oh, you know what?
what? Could we have done? No, we couldn't have done you so. For the inside.
Let's pull the y to the second out again, I guess. When we do that, we get what? We get 4 y squared under here, don't we?
Yeah, 4y.
So if you integrate that.
That's a perfect square.
Sadly, it is not.
Oh, no, it's not.
Okay, we're going to have to turn it inside out, though. What do I mean by that? Don't you wish you could distribute that? But you can't. So it's going to be pi over 4. Y squared out here. We're going to let u equal this. Watch what happens. U equals 4 plus y squared. Okay?
Mm-hmm.
And so if that's the case, then I have the square root of u, don't I?
Yes.
But then what does y squared equal? Because I gotta replace that.
Oh, y squared equals u minus 4. Or form, yeah, u minus 4.
U minus 4 is right. So I'm going to go u minus 4 here. Now, I can't have these limits of integration anymore because it's not in terms of u. Okay?
Mm-hmm.
But now I have to have a du. I'm going to replace that.
du is
This is going to be 2y dy equals u,
and
and then dy equals
du over 2y.
y. But what does y equal? Y equals
The
the square
square
root
root
of.
u over 4. U minus 4.
Okay, so what do we get to? Pi over 4 times the integral of u minus 4 times u to the 1/2 times 1/2, right? The y is on the bottom, so I'm going to say that's u minus 4 to the negative 1/2, right? You see what I'm doing?
Yes.
Times the u. Okay, pi over 4 times the integral, and these I can multiply together.
Yeah, and then you would get just 1/2 u minus 4 to the 1/2, right?
Minus 4 to the 1/2 times u to the 1/2. I just brought this 2 out here.
Mm-hmm.
5/8, and then I multiplied these two together and got u minus 4 to the 1/2.
Du.
And then, yes, du. And now since these are both to the 1/2,
They can't.
no,
No.
you can multiply them together.
In.
This is pi over 8 and the integral of u
4u to the 1/2.
I don't know how to integrate that.
Am I good? Hello?
I'm listening. Can you hear me?
Yeah, I can hear you.
I'm thinking out loud of how I'm going to integrate that.
Oh gosh. Because you can't do another u sub.
Oh my gosh, I'm not sure how to integrate it. I might have to get back to you on that one. Can I get back to you on that one?
Yeah. Man, that's a hard one.
Well,
Just the y part.
maybe I'm not seeing how to integrate that, right away.
Yeah, because sometimes the inside of the root is nice because you can substitute it because the derivative of the inside would be like the y.
No, absolutely. I agree.
But in this case,
Not helping.
mm-mm.
All right, so I'll have to get back to you on how to integrate that one.
Okay.
All right, what's the next one? Is area, I think. On the area, no, wait, number 5. This is number 5. The figure shows the region R in the xy plane, bounded below y equals x squared and y equals b. On the left, x equals 0. Okay. Squared. Y equals b. And left by x equals 0, which is the y-axis. So this is the area. All of this obtained by revolving R about the vertical line x equals a, lying to the left of the region. Using shells. He taught you how to use shells?
Yeah.
I'm not an expert at shells, but let me look at my book here.
Shells for me, let's see, what section? I think it's section, chapter 6.2 is mine.
Yeah, my copy too. Okay, so that's my picture. And we're revolving it around the line x equals a.
Okay, let me copy this down because yours looks less confusing than his. Y equals B. Okay. Got it.
Okay, so then the formula
Is we
is
can take out 2 pi out.
2 pi times the integral from,
It would be the radius times the shell height, which is the radius times the function.
radius. Wait. Times dx. All right. And the radius by definition is this distance right here, isn't it?
Mm-hmm. So it's
This is r, right?
mm-hmm.
Oh, when we're doing it with respect to,
With respect.
so the radius is going to be x squared minus 0, right?
Mm-hmm. Well,
No. The shell radius is from, wait, I got it wrong. The shell radius is, I have a slice right here. So it's this distance. This is r. It looks like. You agree?
x.
Now it's going to be x plus a, isn't it?
Oh, yeah. Mm-hmm.
So shell radius equal to x plus a, right? Because it's the distance from here to here is x, and then we're adding a to it. Right?
Yeah.
Right? It's going to be whatever that y equals, which is, oh wait, no, it's going to be upper minus lower.
Lower.
So it's going to be b minus
X squared.
All right, so our volume is going to be equal to, and we're going to go from x equals 0 to
B squared. Is there a value for that?
no, what you're going to do is you're going to say b equals x squared.
Oh, square root of B.
B, yeah. So the integral is going to be 2 pi times the integral from 0 to root b of the shell radius, which is x plus a
Times
b minus x squared dx. And to integrate that, we're going to multiply it out.
So
dx.
bx minus x to the x cubed
Good.
plus ab
Minus ax.
minus a. Wow.
But that's not hard to integrate. I mean,
These are just constants.
yeah, so that's going to be bx squared over
2
minus x to the 4th over 4
plus abx
abx
minus x cubed over 3.
Evaluated between 0 and b. Oh, root b. I'm sorry, it's root b. Pi times, well, root b squared is
B.
b times b, which is b squared over 2, minus b squared over 4, right? Because plus
A times
b root b minus a root b cubed is going to be b
times B cubed.
Now, because remember, root b cubed is going to be root b times root b
times root B.
That's
Yeah.
root b. Gosh, and guess what? We get to plug a 0 in.
Yay, minus 0.
And what happens to the a root? What happens? Oh, I got to put this over 3. So that's going to be 3 minus 1 of these is 2 of these.
Yes.
So it's going to be 2 pi times, and this is going to be b squared over 4 plus 2 a b root b over 3.
Wow, what a problem.
And then that's only part 1. And part 2 says that we use the washer method, which I like a whole lot better.
Oh, yes.
Oh, okay, just so we're going to check it using the washer method. Right. Okay. So that means the washer method with my picture here. Here. X equals A. Y equals B. Y equals X squared. This is my area I'm revolving. So this is going to be, big R, right, for the washer, and this will be R.
Okay, so
This is one, right?
and then big R,
Big R is equal to
X squared plus A.
no. Big R. It has to be in terms of Y now because
Oh, right.
root Y, because X equals root Y.
Mm-hmm.
The big R is going to be root Y plus A. Yes.
I just had it backwards.
Little R is just going to be little R is A.
Yeah.
So the volume is pi R squared H. So it's going to be the integral from 0 to D, because that's what Y is going from and to. Well, big R squared, which is root Y plus A quantity squared minus
A squared dy.
dy. And this is going to be pi times the integral of 0 to b. Got to multiply this out. So it's going to be root Y squared, which is Y, plus
2a root y.
So 1/2 plus A squared minus A squared.
Oh, look at that.
Who wouldn't want to do the washer method in the first place? Okay, so we get pi times, now let's integrate this, we get
0.
pi squared over 2 plus 2a times pi to the 3/2 times 2/3.
So
0 to b. So that equals pi. Now let's plug this stuff in. We get b squared over 2
plus 2a, and again,
it's going to be 4
thirds a.
4 thirds. B, the square root of b cubed, which is b, right?
What happened to the a? There's a 2. It was a 2a.
Here, there's an a in there. Sorry. Minus 0. I would be so happy to see it. Now this is equivalent to our answer above, because if you in our answer above distribute this 2, we get squared over 2. Yeah. Well, except for we get the same answer. I'm so happy.
Yay.
I hope this is your test.
I hope so too. Well, in the email, he said, here's a practice test, slightly longer and slightly more difficult than the test.
Wow. Okay. So let's see what number 6 does. The tank is formed by rotating the curve around the y-axis.
Oh, man.
Well, what does that mean? That's x squared minus 1 equals y.
That doesn't look like such a bad function. And then it's from 0 to 3. Oh, how to put it in terms of x.
Okay, so x squared minus 1, because it's x equals y squared plus 1, right? So I just squared both sides and moved the 1 over. And then this is the positive side. Okay? And so we're going to take this and we're going to rotate it around the y-axis, it said, from 0 to 3. Right here. And so this is 2. Tank is filled with a fluid of a weight of 8,000 newtons per meters.
So that's
to a height of 4 meters above the tank. Okay, so this is going to be d or delta y. And so the area yes. Right? And its volume is going to be pi r squared h. And this is r, and h is delta y.
Okay.
So delta v is going to be pi r squared. Well, what is r? R is this exponent here, which is root y squared plus 1 squared delta y is its height. So this is pi r squared h. You need a slice of the volume.
Mm-hmm.
I think. Yes. Okay. Now, we know that we're going to have 8,000 newtons per meters cubed, cubic meters. And we're going to multiply that times delta V to get, meters cubed to cancel. And then that's going to be the force. Remember, because work is equal to the integral from A to B of f of x, or y in this case.
Times the distance, so dy.
Right, okay, so we know that it's going to be 8,000 times pi times y squared plus 1 times delta y. So we're going to put that in the force category, right?
Mm-hmm.
And then don't we have to put a component where we're lifting it a certain amount to 4 above?
Like
so would it be 4 minus?
Yeah.
4 minus y? No, 7 minus y. Because we're lifting it 7 up.
I mean, tank is filled with fluid. Find the work done in pumping it to a height of 4 meters. Yep. Mm-hmm. Yeah, 7 minus y times that. The delta V.
So this is going to be from 0 to
3 or 7.
Yeah, I think it's going to be 7, isn't it? Because
But the region of it is shaded to 3.
I know. Is it going to be 2 integrals then? It's going to be from 0 to 3 and then from 3 to 4 because that area is constant above?
I honestly have no idea.
I think so.
I don't work down to height above.
You know what I'm saying? What I'm saying is if we're going to raise the fluid, is it going to be full? Is it full? Does it say full?
The tank is filled. I don't know if filled is full or half full or.
Find the work done in pumping fluid to a height 4 meters above the top of the tank. So, but the top of the tank is, it's like I don't have this part anymore. You know what I mean? It's like the top of the tank stops at 3.
Mm-hmm.
And we're going to raise it 4 more. And so once I get to the top of the tank, this is a constant area, isn't it?
Yeah, because, there's no more
So I think we're going to go from 0 to 3 of our fancy little function.
Mm-hmm. 0 to 3 of 7 minus, would it still be 7 minus 4 or 3 minus 4?
I'm trying to think. No, it's going to be 3 minus, isn't it? Because then we're going to do the other one. I think that's the first one. Plus
The integral from
3 to
3 to
7. Now this is going to be a constant r now. So what r is going to be is 3. Constantly above here, right?
Yeah.
Not varying anymore. So it's going to be 8,000 pi. R squared is just 9 times the height, which would be 7.
7 minus 3. Or minus y, 7 minus y.
Right? Y. I think that's what you got to do.
Yeah.
Because above the tank, you're going to have a constant radius of 3.
Yeah.
I think that's what you got to do, kid. Now you can ask him tomorrow, can't you?
Yeah. And he has office hours on Fridays before class, so I can also ask him before then.
And so I think you know how to integrate this, right? By multiplying this out.
Yeah.
And the same thing here.
Mm-hmm.
So and then I think that you should ask him about number 7. Because not only are you lifting a barrel, at the
But
same
sand is
time,
being poured in.
something's being poured in.
Yeah. All right. And then if it's not too much trouble for you.
I don't mind meeting again with you tomorrow. That's fine. I think 7 is hard enough, you know?
Yeah.
And I don't know how to integrate that other one. That's the only other thing I don't know how to do. But I can figure out that and send you a picture of it later or something.
Yeah. So if we could meet again tomorrow.
At 7?
At 7.
Yeah. Okay.
That would be great. Well, thank you so much.
Well, I wish I could integrate that one, you know?
Yeah.
I just got to think about it. And then I think we set this other one up right. The one that we just did with the work.
Yeah. I'll solve it out, like finish it out once I get back to my dorm and see what I get.
All right. Okay. Well, have a good night.
Thanks, you too.
I'll talk to you later.
Talk to you later. Bye.
Bye.